Hey guys, today I'm going to show you how temperature and concentration affect the rate of reaction. I'm going to demonstrate this with a classic reaction called the Iodine Clock reaction, where a transparent solution suddenly turns into that deep blue color all on its own. So first, what is rate of reaction? Rate of reaction is essentially the speed of a reaction, or how fast the reaction happens. So let's test it. Here we have two flasks with the exact same proportions of the exact same chemicals. The only difference here is that the left one is at a higher temperature than the right one. So I want you to predict which one will change colors first. Now let's see what happens. If you predicted the lower temperature, well, you're wrong. If you predicted the higher temperature, you are correct. Good job. So now we see that raising the temperature of one flask increased the rate of reaction because the flask with the higher temperature changed color first. Therefore, the higher the temperature, the higher the rate of reaction, or the faster the reaction happens. This is because at a higher temperature, the particles are moving much faster, leading to more collisions, and more collisions lead to more individual reactions. That's why at a high temperature on the left side, more products will form in the same amount of time. Now let's test concentration. The flask on the right has a higher concentration of potassium iodide, which is one of the reactants. Which one do you predict will change color first? Let's see. Dang, that had me on the edge of my seat. I thought the other one would catch up. But you're smarter than me, so you probably predicted the one with the higher concentration would change color first. And you, my friend, are correct. So now we can see that the higher the concentration of reactants, the higher the rate of reaction. But why does this happen? At higher concentrations, there are more reactant particles in the same amount of space, so it's much more crowded. In this animation, there are much more orange particles on the left side than the right side. This leads to more collisions, which lead to more reactions. As you can see, more products will form on the left side in the same amount of time. So again, more collisions lead to a faster overall reaction. To sum things up, the higher the temperature, the faster the rate of reaction, and the higher the concentration of reactants, the faster the rate of reaction. This is because when more collisions occur, more reactions happen. And if you think about it, technically you are not just seeing one reaction. You're really seeing millions of individual reactions happening simultaneously, giving you this amazing color change.